The derivation is nothing but the electric due to electric dipole, the intensity, the electric field intensity due to a dipole we have discussed, that is along the axial line. Hope so you don't have any doubt in that part. So I'll proceed with the next derivation. So I'll just recall that. So last expression in bantanta nan heltini, then I'll continue with the next part. Yes, see. The electric field intensity is given by, it is 1 upon 4 pi epsilon naught Q divided by R square. This is our basic expression. The electric field intensity due to the dipole is given by 1 upon 4 pi epsilon naught 2p divided by R cube. So this is due to the dipole and along the axial line anta helbodu. So next we are going to see with the next derivation. Diagram part I have explained you in the last class. So today derivation part we are continuing. Then after that torque and the Gauss law for today's class. Okay. Yes. So ನಿನ್ನೆ ನೋಡಿದ್ವಿ ಅದೇ ಸೇಮ್ ಡಯಾಗ್ರಾಮ್ ಅನ್ನ ನೀವು ಇಲ್ಲಿ ನೋಡಬಹುದು. See here, that is the electric dipole plus Q minus Q we have. Okay, 1 minute. I'll take one blank slide also so that I can explain you. Okay. So diagram here you might have seen. ಇಲ್ಲಿ ನೀವು previous slide ಅಲ್ಲಿ ನೋಡಿರೋ diagram ಮತ್ತೆ ಈಗ ನೋಡ್ತಿರೋ diagram ಸ್ವಲ್ಪ ಚೇಂಜ್ ಆಗುತ್ತೆ. ಯಾಕೆ ಚೇಂಜ್ ಆಗುತ್ತೆ ಅಂತ ನಾನು ನಿಮಗೆ ಹೇಳ್ತೀನಿ. ಅದು ತಗೊಂಡು ಕೂಡ explain ಮಾಡಬಹುದು, no problem. See, suppose this is a dipole. AB is a dipole. Here is a plus Q and here there is a minus Q. Due to the equatorial point, we are calculating the electric field intensity. So ಇಲ್ಲಿ point P ಇರುತ್ತೆ. Due to this point P, we are calculating the electric field intensity for this dipole. Okay. So axial allenittu illittu, but here it is at the bisector athwa at the perpendicular distance anta helbodu. Yes. So now we are joining this AP. This is external construction, and we are joining this BP also. Okay. Here the perpendicular distance is taken as R. 2A is the AB dipole length. A is the AO and this is OB is also A. Okay. Now here whatever the AP and BP distance is there, AP BP distance anna nanu inne helidde nimge, I'll just continue with that. We calculate by using the Pythagoras theorem. So by using the Pythagoras theorem we can write it as what? Under root of A square plus R square. It is under root of A square plus R square. Suppose if you want AP square BP square, root hogatte A square plus R square anta baratte. Okay. So this is the value of AP and BP. Till here we have completed. Now what we need to see is, as we know that in day before yesterday's class, if you have a point charge, if you have a positive point charge, the electric field lines will be outward in direction. Electric field lines enagatte, they will be outward in direction. Okay. Suppose if you have a negative charge, the electric field lines will be inward in direction. The electric field lines are inward in direction. Correct? Yes. So with respect to this concept, here you can see at A point alli enide plus Q ide. So plus Q ige enagatte antandre the electric field intensity will be outward in direction. It will be outward in direction. So this is the direction of your electric field intensity E1. Idu nimdi E1 anta agatte. Okay. Same way minus Q ide. So for minus Q the electric field intensity will be along this direction. So this is nothing but your E2. Is it clear? E1 and E2. Why we are showing the lines outward and inward? So the outward, it means that the positive charge is there. Therefore you have that. And inward because of the negative charge. E1 and E2. Yes. Okay. So now due to this E1 and E2, the electric field intensity, the resultant electric field intensity will be along this direction. Electric field intensity will be along this direction. Is that clear? Okay. So ee ರೀತಿಯಾಗಿ ಮಾಡಬಹುದು. ಕೆಲವೊಂದು ಟೀಚರ್ಸ್ ಡಯಾಗ್ರಾಮ್ ಅನ್ನ ಈ ರೀತಿಯಾಗಿ ಕೂಡ ಡ್ರಾ ಮಾಡ್ತಾರೆ. ನೀವು ಇಲ್ಲಿ ನೋಡಿ. That is here we have the plus, sorry, allenittu plus q ittala. So here I'll take minus q, here I'll take plus q. This is A and this is B. This is the point P and this is the perpendicular bisector. Minus q plus q ide. And here we have the external construction AP and BP value. Now here il minus q irodrinda the electric field intensity will be inward in direction. Illi plus q irodrinda the electric field intensity will be outward in direction. Is that clear? And the resultant electric field intensity will be like this. So what is the difference in both the figure? New dipole plus matte minus L tagonತೀರಾ ಅದ್ರ ಮೇಲೆ ಡಿಸೈಡ್ ಆಗುತ್ತೆ. ಗೊತ್ತಾಗ್ತಾ ಇದೆಯಾ? So where you are taking your dipole plus and minus, based on that you can see the electric field intensity direction. So ಯಾವ್ದು ಕರೆಕ್ಟ್ ಅಂತ ಹೇಳಕ್ಕೆ ಬರಲ್ಲ, ಎರಡು ಕರೆಕ್ಟ್ ಆಗಿದೆ. Both are correct here. It depends on your dipole. So dipole plus ಎಲ್ಲಿ ಬರುತ್ತೆ, minus ಎಲ್ಲಿ ಬರುತ್ತೆ. Based on that we have this E1 and E2 value. Hope so it is clear to you, the diagram part. Okay. So now we are going to write the expressions E1, E2. ಅದೇ ಯಾವ ರೀತಿಯಾಗಿ ಮಾಡಿದ್ವಿ, E1, E2 net electric field intensity, same we are proceeding. But here angle concept will come later. Okay, so now the next step is, so what we are going to do is E1 is equal to 1 upon 4 pi epsilon naught Q divided by, so E1 is due to plus Q charge. So therefore this will be AP square anta agutte. So you can substitute the value of AP square. The AP square value is written as what? A square plus R square. This is my equation 1. Hope so you are understanding. If you are not understanding, please tell in the chat box. E2 is equal to, so at B, so minus Q ige E2 bariri. It is 1 upon 4 pi epsilon naught Q divided by A square plus R square, because both are right angle triangle. APO, BPO, ಎರಡು right angle triangle ಇರೋದ್ರಿಂದ E1, E2 value same ಬರುತ್ತೆ students. You can see there. Correct ಆಗಿದ್ಯಾ? Yes? Understanding? Yes or no? Please tell. Okay, so here some angle is there, that is theta. This is also angle theta. Here also angle theta. This is also theta. And this is perpendicular. And this is my resultant. Okay. So E1 and E2 values are clear to you. Now you can see that E1 is equal to E2. Yes or no? Your E1 is equal to what? It is E2, because both are 1 upon 4 pi epsilon naught Q divided by A square plus R square. Correct? Therefore, the net electric field intensity is given by net electric field intensity is given by E is equal to E1 plus E2 ಅಂತ ಆಗುತ್ತೆ. But E1, E2 ದಲ್ಲಿ ಏನಾಗಿದೆ ಅಂದ್ರೆ ಎರಡು ಸೇಮ್ ಇರೋದ್ರಿಂದ 2E1 ಅಥವಾ 2E2 ಅಂತ ಬರ್ಕೊಳ್ಬಹುದು. Either you can write 2E1 or you can write 2E2. Anything is fine. So you can write 2E1 also, you can write 2E2 also. Okay. And any one value you can substitute. ಎರಡು ಸೇಮ್ ಇರೋದ್ರಿಂದ ಯಾವ್ದು ಬೇಕಾದ್ರೂ ಬರಿಬಹುದು. 1 upon 4 pi epsilon naught Q divided by A square plus R square. Any one equation you can write it. Understanding? Okay. So now you can see here one concept we are introducing. See here what is happening here in the previous slide. I'll show you. You can try to take it, no problem. Because both are same only, no? 1 upon 4 pi epsilon naught Q divided by A square plus R square. Equation 1, equation 2 both are same. Therefore, you can write either 2E1 or you can write 2E2. Or else in general, I can also take it as what? E1 is equal to E2, which is equal to small e ಅಂತ ನಾನು ಡಿನೋಟ್ ಮಾಡಬಹುದು ಫಾರ್ ಮೈ ಕನ್ಸಿಡರೇಷನ್. ನಿಮ್ಗೆ ಅರ್ಥ ಆಗ್ಲಿಕ್ಕೆ ಅಂತೇಳಿ ಸ್ಮಾಲ್ ಇ ತಗೊಂಡು ಅದನ್ನ ಇಲ್ಲಿ ಅಂತ ತಗೊಂಡ್ರು ನಡೆಯುತ್ತೆ. Anything you can do, because here equation 1 will be equal to equation 2. No, there will be no change. ಸೊ ಯಾವಾಗ ಪೊಟೆನ್ಶಿಯಲ್ ನೆಕ್ಸ್ಟ್ ಚಾಪ್ಟರ್ ಅಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡ್ತೀರಾ ಅವಾಗ ಪ್ಲಸ್ ಮೈನಸ್ ಮ್ಯಾಟರ್ ಆಗತ್ತೆ. ಬಟ್ ಇಲ್ಲಿ electric field intensity ಹೇಳ್ತಿರ್ಬೇಕಾದ್ರೆ plus minus matter ಆಗಲ್ಲ. Therefore here E1 is equal to E2. No problem in that. Okay. Yes. So here the next point in this derivation is, you can see here students. See, whatever your E2 is there, so here your E2, what you are seeing, no? The resultant electric field intensity, because here whatever you are writing for the, so one more diagram I am showing you. This is minus Q, this is plus Q, and here we have the electric field intensity E1, and this is our electric field intensity E2. This is the resultant electric field intensity. Okay. I can do this external construction also. So as you are seeing here, students, ಇಲ್ಲೇನಿದೆ E1 ಮತ್ತು E2 ಏನಿದೆ resultant intensity ನೋಡ್ತಾ ಇದ್ದೀರಾ, resultant electric field intensity. This is along what? This is along the x-axis. Yes or no? So ನೀವು last year, first year ಅಲ್ಲಿ vector analysis ಕಲ್ತಿರ್ಬೋದು. So in the vector analysis, you might have learned that so here this is R is the resultant vector. ಇಲ್ಲೇನಾಗತ್ತೆ R cos theta ಅಂತ ಆಗತ್ತೆ, ಇಲ್ಲೇನಾಗತ್ತೆ R sin theta ಆಗತ್ತೆ. ಗೊತ್ತಾಗ್ತಾ ಇದೆಯಾ? ಸೊ ಇಲ್ಲೇನಾಗಿದೆ ಅಂತಂದ್ರೆ, this is your resultant electric field intensity. So along this direction it will be E cos theta, and along this direction it will be E sin theta. Correct? So as you are seeing in the figure, the resultant is along what? It is along the y-axis. Yes or no? You can see in the figure. So resultant ಏನಾಗಿದೆ along y-axis ಬರ್ತಾ ಇರೋದ್ರಿಂದ, therefore the resultant field intensity is written as 2E cos theta. Your resultant electric field intensity is along the y-axis. So therefore here whatever the resultant field intensity you are writing, that you can write it as what? 2E1 or 2E cos theta anta baribodu. Why it is cos theta? I am telling you, because here whatever the resultant 2E cos theta anta you can write, because sin theta yakilla, because it is not along the sorry, y-axis illa, x-axis irodrinda x-axis alli along the y-axis. Yes, okay. Okay. So this is 2E cos theta. Now once you find out the value of cos theta, you can substitute in equation 3. ನಾನೀಗ ಏನ್ ಮಾಡ್ತೀನಿ, ಲಾಸ್ಟ್ ಅಲ್ಲಿ ಏನಿದೆ ಇದನ್ನ equation 3 ಅಂತ ತಗೊಳ್ತೀನಿ. So this is my electric field intensity, net electric field intensity. That is cos theta is equal to. So cos theta is equal to what we can write? Cos theta is equal to, so from the figure it is nothing but A divided by small a divided by AP. ನೀವು ಬೇಕಾದ್ರೆ ಟ್ರಯಾಂಗಲ್, ರೈಟ್ ಆಂಗಲ್ ಟ್ರಯಾಂಗಲ್ APO ಕನ್ಸಿಡರ್ ಮಾಡಿ, ಅಥವಾ BPO ಕನ್ಸಿಡರ್ ಮಾಡಿ. ಯಾವುದು ಟ್ರಯಾಂಗಲ್ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರು ಕೂಡ ನಿಮ್ಗೆ ಸೇಮ್ ಬರುತ್ತೆ. ಬೋತ್ ಯು ಆರ್ ಗೆಟಿಂಗ್ ಇಟ್ as same. So cos theta from the figure, right angle triangle APO or BPO, the cos theta value is given by A divided by AP. That is adjacent divided by hypotenuse. Correct? So which is equal to A, you keep as it is. AP value, AP ನಾನು ಇಲ್ಲಿ ಬರ್ದಿದ್ದೀನಿ ನೋಡಿ, you can see here. The AP value is written here. ನೋಡ್ತಿದ್ದೀರಾ? AP value is written here. So you can substitute the value of AP. So this is equal to under root of A square plus R square, A square plus R square. Therefore, our equation 3 becomes the net electric field intensity is equal to 2 into E value baridi students, either equation 1 or 2, 1 upon 4 pi epsilon naught Q divided by R square plus A square, and your cos theta is what? A divided by under root of A square plus R square. It is A square plus R square. Correct? Okay. Two into bracket, one up equation 3 I am writing 2e cos theta is. So 2 I am writing as it is 1 upon 4 pi epsilon naught q divided by r square plus a square. Cos theta value is taken from the triangle a divided by under root of a square plus r square. Therefore, the final expression is given by the net electric field intensity is given by 1 upon 4 pi epsilon naught 2 into a into q numerator divided by r square plus a square raised to 3 by 2. ಹೇಗ್ ಬಂತ ಹೇಳಿ? See why we are getting to the power of 3 by 2? ನೀವಲ್ಲಿ ನೋಡಿ ಏನಿದೆ, where whatever you are seeing there, denominator term, one is in the root. Yes, so ಒಂದು ರೂಟ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ, ಒಂದು ವಿದೌಟ್ ರೂಟ್ ಇದೆ. ಸೊ ರೂಟ್ ಅನ್ನ ನಾವು ಯಾವ ರೀತಿಯಾಗಿ ಬರಿಬಹುದು? ರೂಟ್ ವ್ಯಾಲ್ಯೂ we can write it as to the power of 1 by 2. Root value we can write it as to the power of 1 by 2. Yes. So see, ನೀವು ಈ ತರ ಕನ್ಸಿಡರ್ ಮಾಡಿ, ನಿಮ್ಮ ಹತ್ರ 2 into root 2 ಇದೆ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. What you can do, 2 ಅದೇ ರೀತಿಯಾಗಿಡಿ, 2 raised to root 2 ಅಂತ ಅಂದ್ರೆ 2 to the power of 1 by 2. So ಇದನ್ನ 2 raised to 1 plus 1 by 2 ಅಂತ ಬರಿತೀವಿ. That is nothing but 2 raised to 3 by 2. ಕರೆಕ್ಟಾ? ಸೊ ನಮ್ಮ ಹತ್ರ ಈಗ ಏನಿದೆ, 2 ಪ್ಲೇಸ್ ಅಲ್ಲಿ a square plus r square ಮತ್ತೆ ಇಲ್ಲಿ ರೂಟ್ ಅಲ್ಲಿ ಏನಿದೆ a square plus r square ಅಂತ ಇದೆ. So therefore this becomes a square plus r square into a square plus r square to the power of 1 by 2. So 1 by 2 plus 1 is nothing but what? A square plus r square to the power of 3 divided by 2. Now you see. Yes, the last step is remaining from the derivation. ನಾನು ಅದನ್ನ ಹೇಳ್ತೀನಿ, ಕಡೆ ನಿಮ್ಗೆ ಏನು ಅರ್ಥ ಆಗ್ಲಿಲ್ಲ ಅಂತ ಕೇಳಿ. The net electric field intensity is equal to 1 upon 4 pi epsilon naught. What is 2a into q? The product of the distance 2a ಅಂತ ಅಂದ್ರೆ dipole length ಆಗತ್ತೆ, q ಅಂದ್ರೆ charge ಆಗತ್ತೆ. What is 2a into q is called as? ಎದ್ರಿಂದ ಡಿನೋಟ್ ಮಾಡ್ತೀವಿ? Yes, what it is denoted as? Why you are forgetting the definition? ಇಲ್ಲಿ ನೋಡಿ, the dipole moment is defined as the product of the distance into any one of the charge is called as dipole moment. Correcta? So ಇಲ್ಲಿ 2a into q ಇದೆ, clear ಆಗಿ ಕೊಟ್ಟಿದ್ದಾರೆ. So therefore it is nothing but what? P. So this is your final expression, students. The net electric field intensity is nothing but 1 upon 4 pi epsilon naught P divided by r square plus a square to the power of 3 divided by 2. So this is your final derivation. For 5 mark, it is important. See. Yes. Now you tell me, derivation is clear to everyone or should I explain once again? ಏನಿಲ್ಲ, ಜಸ್ಟ್ ನಿಮಗೆ ಡೈಗ್ರಾಮ್ ಪ್ರೀವಿಯಸ್ ಅಲ್ಲಿ ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಮ್ಯಾಥಮೆಟಿಕಲ್ ಸ್ಟೆಪ್ಸ್ ಇತ್ತು, ಇಲ್ಲಿ ಸಿಂಪಲ್ ಇದೆ, ಬಟ್ ಡೈಗ್ರಾಮ್ ಯು ಹ್ಯಾವ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಕ್ಲಿಯರ್ಲಿ. ಡೈಗ್ರಾಮ್ ಇಸ್ ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಸಿ ಡೈಗ್ರಾಮ್ ಒಂದ್ಸಲಿ ಅರ್ಥ ಆದ್ರೆ ದ ಡೆರಿವೇಶನ್ ಯು ಕ್ಯಾನ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್. ಸೊ ಫಸ್ಟ್ E1 is ಎರಡೂದ್ರಲ್ಲೂ ಕಾಮನ್ ಏನ್ ಬರುತ್ತೆ? E1 E2 ವ್ಯಾಲ್ಯೂ, ದ ನೆಟ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇಂಟೆನ್ಸಿಟಿ, 3 ಸ್ಟೆಪ್ ಕಾಮನ್ ಇದೆ. ಓನ್ಲಿ ದ ಥಿಂಗ್ ಇಸ್ ವಾಟ್, AP ಅಲ್ಲಿ ಏನ್ ಡಿಸ್ಟೆನ್ಸ್ ಏನಿ ತಗೊಳ್ತೀರಾ ಅದು ಒಂದು ಚೇಂಜ್ ಆಗತ್ತೆ. Then here cos theta will come. ಅಲ್ಲಿ ಏನ್ ಮಾಡ್ತೀರಾ? ಅಲ್ಜಿಬ್ರಾಯಿಕ್ ಫಾರ್ಮುಲೈಸ್ ಯೂಸ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀರಾ. ಗೊತ್ತಾಗ್ತಾ ಇದೆಯಾ? Okay. Hope so it is clear to everyone. Yes. Okay. See Ramya. So hope so diagram is clear. AP value, BP value, Pythagoras theorem ಇಂದ ಬಂದಿದೆ. E1 is equal to 1 upon 4 pi epsilon naught Q divided by AP square. Okay, so AP square value from the Pythagoras theorem, from the figure we have calculated, it is a square plus r square. Next, E2 is equal to 1 upon 4 pi epsilon naught Q divided by a square plus r square. This is our equation 2. The net electric field intensity is given by what? E1 plus E2. ಅಲ್ಲೇನಾಗಿತ್ತು along the axis ಇದ್ದುದ್ರಿಂದ E1 plus E2 ನೇ ಆಗ್ತಿತ್ತು, ಬಟ್ ಎರಡು ಅಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಇರುತ್ತೆ. ಇಲ್ಲಿ ಅಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಇದೆ, ಬಟ್ ಏನಾಗ್ತಾ ಇದೆ, ದಿಸ್ ಇಸ್ ಫಾರ್ಮಿಂಗ್ ಎ ಟ್ರಯಾಂಗಲ್ ಶೇಪ್. ದಿಸ್ ಇಸ್ ಫಾರ್ಮಿಂಗ್ ಎ ಟ್ರಯಾಂಗಲ್ ಶೇಪ್. ಅಲ್ಲೇನಾಗಿತ್ತು ಈ ತರ ಇತ್ತದು, ಬಟ್ ಹಿಯರ್ ಇಟ್ ಇಸ್ ಇನ್ ದ ಟ್ರಯಾಂಗಲ್ ಶೇಪ್. ಸೊ ಟ್ರಯಾಂಗಲ್ ಶೇಪ್ ಇರೋದ್ರಿಂದ the net resultant field will be along this direction. So therefore E1 plus E2 anta baratte. Therefore E is equal to 2E cos theta. Cos theta value anna ನೀವು ಇಲ್ಲಿ figure in that the right angle triangle APO in the cos theta ತೆಗೆದ್ರೆ it is A divided by AP. A divided by AP value is under root of A square plus R square. So substitute in equation 3. Equation 3 dalli the net electric field intensity is equal to 1 upon 4 pi epsilon naught 2A into Q divided by R square plus A square S to 3 divided by 2. Illen numerator term ide, that is nothing but your dipole moment. That is nothing but your dipole moment. Yes. ಮತ್ತೆ ಯಾವ ಸ್ಟೆಪ್ ತಿಳಿಲಿಲ್ಲ ನೀವು ಸ್ಪೆಸಿಫೈ ಮಾಡಬಹುದು. ಐ ವಿಲ್ ಎಕ್ಸ್ಪ್ಲೇನ್. Otherwise we will go for the next point. Yes. So the next point is, that is the torque we are explaining here, the derivation of the torque. So as you know that torque is nothing but what? It is called as, torque is the twisting force. So 11th standard ಅಲ್ಲಿ ಕಲಿತೀರಾ torque ಅಂತ. Torque ಅಂತ ಅಂದ್ರೇನು? It is nothing but the twisting force. Yes. So ಇಲ್ಲಿ ಯಾವ ರೀತಿ twisting force act ಆಗ್ತಾ ಇದೆ? What is torque here? Let us see. Here the derivation is describing for the dipole again. So dipole ಮೇಲೆ ಮೂರು derivations ಬರುತ್ತೆ. ಒಂದು along the axial line, along the equatorial line electric field intensity calculate ಮಾಡ್ತೀರಾ. ಇಲ್ಲೇನ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ? ಟಾರ್ಕ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ ಫಾರ್ ಎ ಡೈಪೋಲ್. ಸೊ ಇಲ್ಲೇನ್ ಡೈಗ್ರಾಮ್ ಇದೆ, ದಟ್ ಐ ಆಮ್ ಎಕ್ಸ್ಪ್ಲೇನಿಂಗ್ ಯು ಹಿಯರ್ ಫಸ್ಟ್. ಸೊ ದಿಸ್ ಇಸ್ ಯುವರ್ ಡೈಪೋಲ್. ಇದು ನಿಮ್ದು ಡೈಪೋಲ್ ಆಗತ್ತೆ. ಹಿಯರ್ ಇಸ್ ದ ಮೈನಸ್ ಕ್ಯೂ, ಹಿಯರ್ ಇಸ್ ದ ಪ್ಲಸ್ ಕ್ಯೂ. ಡೈಪೋಲ್ ಅನ್ನ ನಾವ್ ಏನ್ ಮಾಡ್ತಾ ಇದೀವಿ? ಇಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇಂಟೆನ್ಸಿಟಿ, ಇದು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇದೆ ಇಲ್ಲಿ. Okay, so we have the electric field. In this electric field we are keeping the dipole. So you will figure al clear ag nodbodu, which you are seeing there. Minus q is there, plus q is there. It is a dipole. It is placed in the electric field. Here you can see the electric field. Idella line, parallel lines ಏನು ಹೇಳ್ತಾ ಇದೆ? Electric field ಹೇಳ್ತಾ ಇದೆ. Okay, ನೀವು ಕೇಳಬಹುದು why the dipole is kept in this direction? Because ನಮ್ಗೆ ಇದೇನ್ dipole ಇದೆ, it should make some angle with your dipole, electric fields. So ಇದil ಏನ್ angle create ಮಾಡ್ತಾ ಇದೆ? Theta be the angle between the electric field and the dipole. Okay, what happens here, students? See, here minus q charge is there. So because of the minus q charge, ಇದು electric field ಅಲ್ಲಿ ಇರೋದ್ರಿಂದ it will experience the force along this direction. Whatever the dipole is there, dipole then minus q charge there, that is experiencing a force along this direction, and the plus q charge is experiencing a force along this direction. Yes. So here what happens? The forces are in the opposite direction. So one v directional ಬರ್ತಾ ಇದೆ, ಮತ್ತೊಂದು force e directional ಬರ್ತಾ ಇರೋದ್ರಿಂದ the dipole will experience a torque. Dipole ಏನ್ ಮಾಡ್ತಾ ಇದೆ ಅಂತ ಅಂದ್ರೆ torque experience ಮಾಡತ್ತೆ. So what is this torque? For example, I have this water bottle. If I am rotating this cap, so when I am rotating this cap, whatever the thumb is there, thumb is trying to move in one direction and the other fingers are moving in the other direction. So that time illenagatte bottle cap mele the forces are acting in the two different directions. So ಒಂದೇ ಆಬ್ಜೆಕ್ಟ್ ಮೇಲೆ ಎರಡು ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಯಾವಾಗ ಫೋರ್ಸ್ ಆಕ್ಟ್ ಆಗತ್ತೆ, ದಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ವಾಟ್? ಟಾರ್ಕ್ ಅಂತ ಹೇಳ್ತೀವಿ. ದಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಟಾರ್ಕ್. ಓಕೆ, ಸೊ ದ ಟಾರ್ಕ್ ಫಾರ್ಮುಲಾ ಇಸ್ ಗಿವನ್ ಬೈ ಫೋರ್ಸ್ ಇಂಟು ಡಿಸ್ಟೆನ್ಸ್ ಅಂತ ಹೇಳ್ತಾರೆ. ಸೊ ನೌ ದ ಡೆರಿವೇಶನ್ ಪಾರ್ಟ್, the torque is given by what? Force into the perpendicular distance. So here the perpendicular distance we need to draw it externally. Aita. So this is A and this is B. Here I'll just take a perpendicular distance. O point anta tagoltivi. Okay. The perpendicular distance is nothing but what? BO. The perpendicular distance is what? BO, or else you can take AO also, no problem. AO kuda tagolbodu, BO kuda tagolbodu. Aita. Therefore, torque is equal to force into perpendicular distance. So here force is given by students. So force anna nanili E into Q anta baritini. Heg bant heli? Because we know that the electric field intensity is given by force per unit charge. The electric field intensity is given by force per unit charge. Therefore, the force is equal to what? E into Q. Force anna navenanta baribodu? E into Q anta baribodu. Into BO. Yes, correct. Okay. So BO, how you will calculate? BO find out madlikke nama hatra yenide. Again, we have to go for the triangle here. So if you see this triangle, BOA, illen triangle OAB athwa BOA en kanista ide. From the triangle, you write it for sin theta is equal to. So sin theta baradri anta andre, it is BO divided by AB anta baratte. Agree? Hope so. Nimage basic mathematics is gottide anta ankoltini. So this BO is equal to what you will write? BO is equal to AB into sin theta. So what is the AB value? AB value yaradru helboda? It is nothing but the dipole length. AB is nothing but the dipole length. So what is the value of dipole length? How we denote the value of dipole length? Last step, very simple derivation, 2 marks. Yes, 2A. Okay. So this is equal to EQ. What is your BO value? BO value is 2A into sine theta. So this is torque is equal to 2A sine theta. One more last substitution. Tau is equal to torque anna tau in the denote ಮಾಡ್ತೀವಿ. Tau is equal to E ಅದೇ ರೀತಿಯಾಗಿ ಬರೀರಿ. What is Q into 2A? Again, the product of distance into any charge is nothing but what? P, dipole moment into sine theta. Therefore, torque is equal to EP sine theta. Torque is equal to EP sine theta. Yes, dipole moment, not dipole, dipole moment. Okay. This is 2 marks derivation. Derive the expression for the torque due to a dipole placed in a uniform electric field anta question baratte. Very simple derivation. Is that clear? Yes. Okay. So simple derivation it is. Okay. So illi 1 mark mele in question baratte nodi students. When the torque is maximum, when the torque is minimum. So expression alli enide, the expression consists of the torque is equal to EP sin theta. Torque is equal to EP sin theta. So you already trigonometrical kaltirtira. Sin theta 0 anta andre, the sin 0 will be, it is 0, and sin 90 will be, it is 1. Correct? So therefore, nodi, minimum torque. The minimum torque experienced by the electric dipole in the electric field when it is theta is equal to 0 or 180 degree. So therefore, tau is equal to 0 anta agatte, because our expression is tau is equal to PE sin theta. So sin 0 adre 0 agatte. The torque will be maximum. Sin 90 adre the value will be PE. The value will be PE. Sin 180 adru kuda the torque will be minimum itself, because sin 180 is again 0. So this is MCQ's question, aita. When the torque is maximum, when the torque is minimum. Okay, the next point. So the next point is the Gauss law. Before going to discuss the Gauss law, that is the last part of this chapter, but 3 derivations is constants. No doubt last part is there. but it requires 2 class because derivation, 3 derivations, 3 very very important derivations anta helbodu. Okay, so before going to start with the Gauss law, here Gauss law dalli one term barutte that is called as the electric flux. Hagadre electric flux andre enante heli nodana. See, the electric flux is the rate at which the electric field flows through a given area. The electric flux is directly proportional to the number of electric field lines going through the virtual surface, and the unit of flux is voltmeter. The unit of flux is what? Voltmeter anta heltare. So illen ಮಾಡಿ unit ಬರ್ದಿಟ್ಕೊಳ್ಳಿ. Voltmeter is the unit of electric flux. How you can define? It is the rate at which the electric field flows through a given area. For example, if you have any one place, okay, so suppose this is one surface anta ಇಟ್ಕೊಳ್ಳಿ. When you consider this as one surface, the rate of the electric field lines ಎಷ್ಟಿದ್ರು ಒಳಗಡೆ ಪಾಸ್ ಆಗತ್ತೆ for the particular area, that is called as what? Electric flux. So ಇದನ್ನ electric field lines ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿ. ಈ ಸರ್ಫೇಸ್ ಥ್ರೂ ಎಷ್ಟು electric field lines ಇದ್ರ ಒಳಗಡೆ ಪಾಸ್ ಆಗತ್ತೆ, that area, particular ಏರಿಯಾಗೆ ಎಷ್ಟು ಲೈನ್ಸ್ ಇರತ್ತೆ ಅನ್ನೋದನ್ನ electric flux ಡಿಫೈನ್ ಮಾಡತ್ತೆ. Okay, therefore ನೀವು ಇಲ್ಲಿ ನೋಡಬಹುದು, the electric flux pi is equal to, it is given as E into A. E is electric field intensity, A is the area. So ಇದು ಡಾಟ್ ಪ್ರಾಡಕ್ಟ್ ಇರೋದ್ರಿಂದ ನಿಮ್ಗೆ ಆಲ್ರೆಡಿ ಗೊತ್ತಿದೆ, ಡಾಟ್ ಪ್ರಾಡಕ್ಟ್ ಇದ್ದಾಗ cos theta ಬರುತ್ತೆ, EA cos theta. Yes, it is EA cos theta. So again, so second year ಅಲ್ಲಿ ಯಾವ್ದು ಲೆಸನ್ ಕಲಿತೀರಾ, everywhere you have maximum and minimum condition. So as it is dot product, cos theta ಬರುತ್ತೆ. cos theta, cos 0 ಅಂತ ಅಂದ್ರೆ 0 ಅಂದ್ರೆ 1 ಆಗತ್ತೆ, cos 90 ಅಂದ್ರೆ 0 ಆಗತ್ತೆ. ಸೊ ಯಾವಾಗಾದ್ರೂ ವ್ಯಾಲ್ಯೂ 0 ಆಗತ್ತೆ ಅದನ್ನ zero flux ಅಂತ ಕರೀತಾರೆ. No electric field lines will pass through a surface when it is placed parallel to the electric field is called as what? Zero flux. It is called as the zero flux. The flux is equal to EA cos theta. So theta is equal to, it is 90 degree. So 90 degree anta andre cos 0, cos 90 is 0. Therefore the flux will be 0. Okay. Very simple point. So zero flux or the maximum flux, zero flux or the maximum flux we can see. The last part of the lesson, Gauss law and its applications. So first I'll tell you 3 more definitions before going to start with the Gauss law, which we have left in this last class. Okay, yes. So see here students, that is electrostatic force due to continuous charge distribution. ಇಲ್ಲಿ ಏನಾಗತ್ತೆ ಅಂತ ಅಂದ್ರೆ, ನೀವು ಯಾವ್ದಾದ್ರು ಒಂದು ರೀಜನ್ ತಗೊಂಡ್ರಿ ಅಂತ ಅಂದ್ರೆ, ಆರ್ ಎನಿ ಸರ್ಫೇಸ್ ನೀವು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ, ದ ಚಾರ್ಜಸ್ ವಿಲ್ ಬಿ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟೆಡ್ ಓವರ್ ದ ಸರ್ಫೇಸ್. ಚಾರ್ಜ್ ಏನಾಗತ್ತೆ ಓವರ್ ದ ಸರ್ಫೇಸ್ ಮೇಲೆ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಕರೆಕ್ಟ್? ಸೊ ದೇರ್ ಆರ್ 3 ways for the distribution of the charge. What are the 3 ways here? The first one is called as what? That is linear charge distribution. It is called as linear charge distribution. So this linear charge distribution is denoted by the letter lambda, linear charge distribution. Next we have the surface charge distribution, or you can say that the surface charge density, linear charge density, and the third type is volume charge density. It is volume charge density. So linear charge density, surface charge density, volume charge density. So if you have any surface, the charges will be distributed over the surface. ಯಾವ ರೀತಿಯಾಗಿ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಆಗುತ್ತೆ ಅನ್ನೋದನ್ನ 3 types ಅಲ್ಲಿ ಡಿವೈಡ್ ಮಾಡ್ತೀವಿ. linear charge density, surface charge density, either you can say distribution or we say it as density. Why we call it as density, I'll tell you, because based on the definition it is. So you can see the term now. Yes, so here whatever the first one, linear charge density is there. That linear charge density is given by Okay. The linear charge density is denoted by the letter lambda and it is defined as penny. Okay. That is lambda is equal to the linear charge density. Lambda is equal to, it is nothing but charge per unit length. It is nothing but charge per unit length anta ಹೇಳ್ತೀವಿ. It is called as what? Linear or line charge density anta ಹೇಳ್ತಾರೆ. So why it is called as density? Because you can say that it is the system of closely spaced charges. So illen now distribute ಮಾಡ್ತಾ ಇದೀವಿ. This is restricted for the closed surface, closely packed surface. Therefore, we define it as what? That is in terms of density we can call, or in commonly we can call it as distribution also, no problem. Okay. So what is linear charge density, students? Linear charge density is charge per unit length. Surface charge density is denoted by the letter sigma. Sigma. It is defined as charge per unit area. The volume charge density is defined as, it is denoted by rho, which is equal to charge per unit volume. So linear charge density, charge by length. Surface charge density, charge by area. Volume charge density, charge by volume. Now, if you tell me all the three units, I can proceed for the next point. Okay, linear charge density, the unit en baratte. Formula is there in front of you. Charge by length anta. Unit en baratte heli. What is the unit of charge? Linear charge density unit. So see, you have not studied in first year. See, charge anna coulomb inda denote ಮಾಡ್ತೀವಿ. Length anna meter inda denote ಮಾಡ್ತಾರೆ. Therefore, it is nothing but what? Coulomb per meter, not centimeter. Coulomb per meter. Yes. Tell me for the surface charge density. Surface charge density. It is coulomb per meter square. Similarly, for volume charge density, coulomb per meter cube. Coulomb per meter cube. Yes, agree? The linear charge density Q by L. So therefore, coulomb per meter. Surface charge density, charge by area. Therefore, coulomb by meter square. Last one, volume charge density, charge by volume, therefore coulomb per meter cube. Yes. Okay. So the next point, the last point, Gauss law. So see here, students, what is Gauss law? So Gauss law is nothing but it is a mathematical relation between a closed charge and the electric field intensity that is given by the Gauss law. Hagadre Gauss law ಏನ್ define ಮಾಡುತ್ತೆ ನೋಡಿ. The Gauss law is explaining you about the flux. So ನಾವು ಈಗಷ್ಟೇ ಏನ್ ನೋಡಿದ್ವಿ, the flux is given as what? E into A. ಅಥವಾ ನಾವು ಡಾಟ್ ಪ್ರಾಡಕ್ಟ್ ಅನ್ನ ತಗೊಳ್ಬೇಕಾದ್ರೆ EA cos theta ಅಂತ ತಗೊಳ್ತೀವಿ. This is our flux. But in terms of Gauss law, the flux is defined as charge by epsilon naught. So epsilon naught ಅಂದ್ರೆ ಏನಂತ ನೆನಪಿರಬಹುದು, ಫಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಹೇಳಿದ್ವಿ. The epsilon naught is nothing but what? It is called as the permittivity ಅಂತ ಹೇಳ್ತಾರೆ. ಇದನ್ನ permittivity ಅಂತ ನಾವಿಲ್ಲಿ ಹೇಳ್ತೀವಿ. ಗೊತ್ತಾಗ್ತಾ ಇದೆಯಾ? So what is permittivity? The ability of the surface to allow the electric field lines is called as what? Permittivity. Charge per unit epsilon charge by epsilon naught is called as what? Flux. ಹಾಗಾದ್ರೆ definition ಏನಿದೆ ಅಂತ ನೋಡಿ. Because you have to understand the definition. Here you can see. It simplifies the calculation for the electric field. Okay, here it is there. The Gauss law, illide nodi, second line. The Gauss law states that the total electric flux for the closed surface is always equal to 1 upon epsilon naught times the total charge enclosed by the system. The total charge enclosed by the system. This is called as what? Gauss law. So I'll repeat the Gauss law, how you are defining the total electric flux through any closed surface is equal to 1 upon epsilon naught times the total charge enclosed by the surface. Okay, so therefore this can be written as flux is equal to Q divided by epsilon naught. Yes, is that clear, students? What is flux? What is Gauss law? The charge density distribution. Is that clear to everyone? Yes. Okay. So in the last part, we have the application of the Gauss law. 3 derivations are there. So all the 3 derivations we will discuss in the next class. So next class ಅಲ್ಲಿ derivation ಅನ್ನ continue ಮಾಡೋಣ because it will be heavy for you to again digest that. So we will meet in the next class. Okay. Thank you.